Today we're going to look at the property of orientation and how it relates to the four basic transformations right here that we looked at yesterday. Now, orientation is just the order of the points, and it's either clockwise or counterclockwise. So those are your two options. And one thing that's a big question is whether or not these four transformations preserve orientation, means keep it the same. So like if the pre-image is clockwise, then look and see if the image is also clockwise. So let's look at them. So with the reflection, let's start with the pre-image here. We go from A to B to C. That's clockwise. And then from A prime, B prime to C prime, that is counterclockwise. So with this, does it preserve orientation? No, does not preserve orientation for a reflection. Changes it every time. Okay, with a rotation, we look at this. We got A, B, C going clockwise. A prime, B prime, C prime, also clockwise. So, clockwise, clockwise, this does preserve orientation. With a translation, hopefully this is very easy to see because it's just facing the same direction. That goes clockwise, A, B, C, A prime, B prime, C prime, also clockwise. So yes, translations preserve orientation as well. And dilations, the last one. A, B, C, also clockwise. A prime, B prime, C prime, also clockwise, which means yes. So, a super helpful statement is, oh wow, look, it's magic. Reflections are the only transformations that do not preserve orientation. The orientation switches every time you do a reflection. And it's actually a really easy way to check and see if a reflection happened. So you can just look around the pre-image and look around the image and just decide, are they both going clockwise or are they both going counterclockwise? If they're both doing the same thing, then it's not a reflection. It's either a rotation, a dilation, or a translation. If they're going in different directions, if one of them's going clockwise, the other is counterclockwise, then you know it's a reflection. It has to be a reflection. So right here, there's a few examples of different orientation with this. So if we look at these dancers and we think of the line of reflection as right down the middle here, like that, because, you know, I mean, they're aiming for a symmetrical, same size, congruent and everything. Of course, they're not congruent, but close enough. If we look at it this way, we go from this guy's head to his back and then back around. That is going counterclockwise. And then from her, we go head to the back and down onto the feet. Then that right there is going clockwise. So right there you can see that a reflection happened, different orientations. If we look down at this violin, we have the line of reflection right here. And it'd be really easy to see right here that right there is going counterclockwise. And right here is going clockwise. Now if we look over at a few things with the same orientation, we can look at like these two. These are actually supposed to be synchronized swimmers. It's a diagram of that. So if we look at, say, this one versus this one, why not? If we go from the flower in the hair all the way that way, so if we go that way, we go clockwise. And if we go that way, we go clockwise. Woo! Okay, cool. And this is a rotation right here, going from here to here, rotates, or here to here, either way. This would be a 90-degree rotation. This to this could either be a 270-degree rotation or negative 90 if you go clockwise. Now right here, this is sort of a dilation. I took a little liberties here going from violin all the way up to a bass. But if we look at this, it's dilation getting bigger, 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 bigger. So if we start off here and we go, say, from here around, that is going to be counterclockwise. And we can do the same thing on this. Likewise, counterclockwise, because dilations preserve orientation.